has been a long, slow slog in terms of commercial drone deliveries here in the U.S. going mainstream. Break down this program, this partnership with UPS for us, and why healthcare seems to be, at least at this point in time, potentially the way forward.
It starts with a need. There's a very big need to make healthcare transportation more efficient. So when you look at a hospital system like Stanford, for instance, where I am today, there's typically 5 to 10 facilities that need to be connected for super fast, super reliable transportation. And that's what our system can do. It can avoid roadway delays. It can give very predictable transportation, shrink the transportation time from like 2 hours down to a few minutes. This is all happening under the auspices of a new FAA program called the Integration Pilot Program for Unmanned Aerial Systems. It started in November 2017, and we're midway through it. And it gives us this opportunity to prove out the technology and figure out how it's going to scale. So we're starting at WakeMed with UPS, and we hope within the next couple of years we can take it to many, many hospitals around the country.
Now, I know from a UPS standpoint, they see healthcare as a big area of growth, big opportunities there. How do you see it? Because in addition to this partnership with UPS here in the U.S., healthcare seems to be an area where you've been launching deliveries in other parts of the world as well.
Yeah, that's right. So Matternet has been operating in Switzerland for over a year and a half now. We've conducted over 3,000 flights over densely populated areas, over the cities of Zurich and Bern and Lugano, with our partners there, Swiss Post. And the opportunity in healthcare is massive. I came across a study a couple of years ago mentioning that the amount of waste in healthcare in the U.S. every year amounts to $750 billion. So $750 billion of waste in healthcare every year in the U.S. And waste means capacity that is underutilized. In what we're doing with UPS, for instance, we're starting with looking at labs. Can we centralize lab operations to make them way more efficient? And we believe that we can save an average hospital system between $2 and $5 million per year in lab operations alone. And then we expand from there in bringing medicine to bringing savings in how they stock medicine and how they run their pharmacies and so forth. So the implications for how hospital systems can be run from a cost perspective are, I think, tremendous, and we can have very strong positive impact there. Beyond the cost savings, I think we can use this type of system to massively improve healthcare in the country. So imagine when you have to get that lab result back, how crucial it is to get it on time. And with a system like this, we can deliver these lab results, first of all, the samples and then the results much faster than we can do it with the traditional transportation methods today.
Andreas, in terms of location, delivery locations, what is the sweet spot? When is this really going to matter in terms of medicine getting to people or organizations? Is it U.S.? Is it somewhere in the middle of nowhere?
We believe that there's massive benefit in our urban and suburban areas, right? So in a place like the Silicon Valley or WakeMed, where we with our first customer, WakeMed Health, there's a lot of friction on the road, right? If you want to get from A to B, today, in order to transport that blood sample on demand, it takes anywhere between 2 and 4 hours, depending on location. With our system, it can be 15 to 20 minutes, and it's very, very predictable. And if you can imagine this happening many times a day across many facilities, it amounts to a big benefit. So we believe that as urbanization is growing throughout the U.S. and much of the developed world, we need to figure out better ways to transport things on demand. And drone delivery is enabling us to do that in a very, very predictable way. It has many other benefits as well. So it's lower cost eventually, it's much lower ecological footprint. And again, for healthcare, it really matters that we can deliver a blood sample or a pathology specimen in a very, very predictable amount of time. So you know that the lab sample is going to be there in 5.5 minutes, right? And you have plus or minus of a few seconds. Compare that to maybe between 1 and 3 hours.
Along those lines, what about air traffic when it comes to drones? Because Amazon wants to deliver soccer cleats and toothpaste while you're delivering blood samples. Has the technology been figured out well enough to make sure that the right drones, the right items, get priority when the sky starts going dark with with drone traffic?
Yeah, that's an absolutely critical question. So the whole concept of the FAA program that we're part of is to figure answers to these types of questions out. There is a construct that has been proposed by NASA a few years ago. It's called Unmanned Aerial Systems Traffic Management, and it tries to figure out how the airspace is going to work. That's why these types of operations are so important. So again, last week we started the first ongoing operation. It's not part of a pilot, it's not a test, it's an ongoing operation. And this type of operation gives the FAA data to understand how airspace is going to work. We occupy the lower part of the airspace, below 400 feet. There's usually helicopter traffic in and out of the places that we fly off because we're flying in and out of hospitals. The reason why we've been able to operate successfully in Switzerland and now bring this operation here in the US is because we have figured out a way to do this safely and deconflict with other users of the airspace. Now, how does this scale? What are going to be the technology components that are needed for this to scale? Is one of the key questions that the FAA is trying to figure out, and we're trying to figure it out with them and much of the rest ecosystem in the drone delivery space as well. And one of the key differences when you compare our system with Amazon is that we fly between fixed locations on fixed routes. So the level of complexity is much lower than if one was flying through somebody's home.